tomorrow will be better. Two balls of masses mkg and 20 mkg are both released at the same time from the same height. Which ball falls first? Dear friends, this is a question which many have come across, and many have known the answer to this question to be that the two balls will fall at the same time. But not many really know the science behind this. Not many can explain really why the two balls will fall at the same time. Because at first reasoning, we all know that the heavier ball will fall first. All right, so follow me, dear friends. Solution. Now let's start by providing the equation for time, because the quantity we are talking about here is time. Which ball falls first means which ball will fall at a little time interval. So the simplest equations to use, or the simplest equation to use when dealing with uniformly accelerated motion to find time, is v equals u plus at. In this equation, our u here is going to be 0 because we are told that it's released, as it's clearly underlined there. So released means there was no initial velocity. From here, if you make t the subject, you have that t will be equal to v divided by a. In our context, it will be v divided by g, which is acceleration due to gravity. Now at this point, you can clearly notice that this final equation here doesn't have anything to do with the masses of any of the objects. For this reason, irrespective of the mass of an object, the time of fall is only going to depend on the final velocity and the acceleration due to gravity. Now for the first object, let's call its time of fall t1. It will be given by v1 all over g. I won't say g1 because g will be the same for any object around the same geographical area. And the time of fall for the second object will be v2 all over g. As you can clearly see once more, there is no m figuring out in any of these two equations. For this reason, as long as these two objects are falling from the same altitude and they are released at the same time without any initial velocity, then they will both reach the ground at the same time, provided there is no air resistance in our context, or the air resistance is negligible. This is the only condition for this formula to be true here. So the two balls will fall at the same time. Tomorrow will be better.